In this chapter, we start working on our previous scene. After this video, we will know how to use noise and sound primitives to define where we want the noise to appear. We will use a height gradient to define the noise opacity in the vertical axis. Let's get started. This time, we won't introduce too many new concepts, but we will spend more time tweaking the values trying to get a convincing result. We work in play mode because we want to keep an eye on the GPU profiler to limit ourselves to not overpass 5 milliseconds. The first thing that we are going to do is to activate noise. Now the gradient texture is going to be used to multiply noise, not to make fog. We will see later how to add fog in this situation. Now we readjust intensity within the rendering tab. The next step is to activate height gradient. There are two gradients available, but only one is required in this case. Now we are going to spend some time adjusting the noise parameters. The detail layer is used to add detail to the base layer. It is sampled only when the base layer is visible. With octaves, the amount of base layers can be increased. This helps to add more variation so that repetition is less noticeable. When octaves is greater than 2, there is a new parameter available called curl. This will distort the detail layer, getting a more interesting shape. With absorption, we set how much light is absorbed by medium. It depends on the media density. This means that the more density, the more light is absorbed. Absorption affects ambient and incident light. Let's activate now directional lighting. This module computes the directional light scattering inside of the cloud. We can set the color of the light when it's reflected out. Before we do more visual adjustments, we will try to optimize the renderer settings. With the GPU profiler on screen, we adjust the number of iterations and the distance between them until we get an optimal balance between performance and visual quality. The optimization slider alters the distance between iterations to make them larger at far distances. In this way, we use more GPU power at distances close to the camera. We will try to not exceed 5 milliseconds. Now we are below 5 milliseconds and the quality is quite good. Let's move forward with the funny part. Now that the clouds are mostly done, let's activate volume fog to make the atmosphere. This type of fog is only available for textured volumes and it will fill the empty space left by the noise. More options will appear in the inspector. This fog has its own visibility value and can also be affected by lights. Let's activate the incident light module. As you can see, it's also shadowed. It looks so amazing. In some situations, we can use the guitar slider to add noise in the sampling positions. Then we activate the noise in the camera script to smooth the image. Sadly, the output image can't be in HDR. In this case, bright values of color adds a lot to the visual fidelity of the image, so we will try to avoid it. We don't have shadows far away from the center of the volume, so let's adjust the zoom slider until we have shadows everywhere. Edge softness is used to fade the edges of the shadow map. Performance is quite good, we are below 4 milliseconds. Now we are going to make the clouds limited to a given area. The way to get this is by using primitives. Create a fog volume primitive using the Create menu. This cube is a primitive and it's used to mask noise, so the clouds will only appear inside of this primitive. Now, with our primitive in position, it has to be added to the volume. Within the Renderer tab, enable primitives. Real-time search is enabled by default. Enable it only to refresh the primitive list. Let's use two primitives to make clouds around mountains. Now we have two cubes of clouds. There are more controls to override the original primitive shape. Let's adjust size and softness to turn the cubes into soft volumes. For debug purposes, we can make primitives visible. They are rendered with a red transparent material. The whole atmosphere is rendered in 4 milliseconds. Making clouds is not an easy task, and it can be quite time-consuming. We made this variation of the same scene, introducing some changes in lighting and color. The skybox was replaced with a cirrus layer also made with fog volume, and the cloud shape is more homogeneous. All the atmosphere is rendered with fog volume. Until next time!